O guys, tara, embedded video.
Nasaan ako?
Ito.
Chan.
Kami po ang
Group 4 from 5ECE-C.
Yes, and i-explain po namin yung aming ginawang program na ALU, or in other words, calculator. Tara na.
Hello, Ma'am Giselle. We will now proceed to the simulation of our ALU design. Let's start off with a master reset of the code. Whenever switch 9 is up, all the stored values in the registers will be cleared out. So, including, this means that all the displays, including the 7 segment and the green and red LEDs, will be off, and all the values will be 0. Now proceed with the data storage. In order to store variables, switch 6 should be up. Let us first proceed with the arithmetic operation of decimal numbers. To enable this function, switch 7 and 8 should be down. Our design can store up to 4 variables for every function of the ALU, which can be enabled through different switch 4 and 5 combinations. For variable 1, both switches should be down. For variable 2, switch 5 should be down and switch 4 should be up. For variable 3, switch 5 should be up and switch 4 should be down. For variable 4, both switches should be up. Let us take note that key 1 increments the present value of the ones place, while key 0 decrements it. And also, key 3 increments the present value of the tens place, while key 2 decrements it. And let us also take note that every variable can store values ranging from 0 to 99. Let us now move to the operation on decimal numbers. To enable this function, switch 6 should be down. Initialization will take place, wherein decimal system will be the default system. And also, the accumulator will start at 0 and will be limited to 9999 and will be displayed when switch 3 is up. The 4 variables stored for decimal number system will be used as inputs for every operation, where key 3 corresponds to the variable 1 and so on. The operations can be enabled through different switch 4 and 5 combination, and the results will be stored to the accumulator. For decimal addition, both switches should be down. For decimal subtraction, switch 4 should be up and switch 5 should be down. For decimal multiplication, switch 4 should be down and switch 5 should be up. And to clear the value of the accumulator, both switches should be up. The present value of the accumulator could be converted into different number system through the different combination of switch 1 and 2. For decimal system, switch 1 and switch 2 should be down. For hexadecimal system, switch 1 should be up and switch 2 should be down. For octal system, switch 1 should be down and switch 2 should be up. And for base 5 system, both switches should be up. The binary value of the accumulator is also displayed on the red LEDs. Take note that the value of the accumulator must be retained. Now proceed with the operations of the BCD numbers. In order to enable this ALU function, switch 7 should be up and switch 8 should be down. Also, switch 6 should be up to enable data storage. The default value displayed is 0000. The input accepts values from 0 to 9 in binary, which can be inputted by key 3 to key 0, where key 3 is the most significant bit. If the value exceeds the value of 9, all the red LEDs will light up and the value will not be stored. Our ALU can store up to 4 variables for this number system, using the different combinations of switch 4 and switch 5. Now we move on to the operations on BCD numbers. To enable this function, switch 6 should be down. Initialization will take place where accumulator will be set to 0 and will be limited to 99. The variable stored in BCD number will be used as inputs to the operation using key 3 as variable 5 and so on. The BCD can perform either addition or subtraction, which can be enabled through switch 3. When switch 3 is down, it will perform BCD addition. When switch 3 is up, it will perform BCD subtraction. Take note that the value of accumulator must be retained.
For the last part of the project, logic operations is processed. To be able to proceed with the logic operations, note that switch 7 should be down and while switch 8 should be up. Storing of values was just like with the arithmetic BCD and decimal, wherein switch 5 and 4 are used, while switch 6 is up. Also, inputs will be based on binary numbers. For variable 9, both switches should be down. For variable 10, switch 5 should be down, while switch 4 should be up. For variable 11, switch 5 should be up, while switch 4 should be down. And for the last variable, which is variable 12, both switches should be up. Also, we should take note that when switch 6 is no longer in the up position, the variables must retain their values. When switch 6 is down, the logic operations are now enabled. Accumulator A, which has a limit value from 0000 to 1111 in binary, starts as 0. The contents of the accumulator should be displayed on the 4/7 segment display. To enable bitwise operation to be executed after key press, switches 3 and 2 are used. Let us take note of the values of the registers stored a while ago. So let us put the switch 6 in up position. So in variable 9, the value is 1. In variable 10, the value is 2. In variable 11, the value is 3. And lastly, in variable 12, the value is 4. When switch 3 is down and switch 2 is down also, the bitwise operation NOT is executed. When switch 3 is down and switch 2 is up, the bitwise AND operation is executed. Next, when switch 3 is up and switch 2 is down, the bitwise OR operation is executed. Lastly, when both switches are in up position, the bitwise XOR operation is executed. Please remember again that the values of the keys are 4, 3, 2, 1.
Lastly, to disable the function of the ALU, switch 7 and 8 should be switched up. Yan. And that will be all. Thank you for watching.